molarity. Okay, so I know most of you have heard about this from your high school days, molarity. Now, we all know that whenever we are taking stock of any chemical, or whenever we are trying to take a stock of a chemical, there are several units that we can use to represent those chemicals. So one of the units to represent some of the chemicals we make use of in the lab is molarity. Okay, what is this molarity we're talking about? Molarity is simply the number of moles of a solute that can dissolve in what? In 1 dm cube of a solvent, right? So molarity can be given as, remember that molarity is also, we can also use the term concentration in mole per dm cube to represent molarity. So we can represent molarity as C, or concentration in mole per dm cube. So from the definition, the molarity of a solution is simply the number of moles of a solute that can dissolve in 1 dm cube of the solvent. So mathematically, molarity simplifies, it means moles of solute all over volume of solution in what? In dm cube. Okay? Why the mole, the unit of mole remains what? Like this, right? So the unit of molarity is simply mole per dm cube. Remember that dm cube is also the same thing as liter. So molarity can also be equal to what? Mole per liter. Okay? So also we can represent molarity as capital M, a molar solution. Okay? So all these are units of the molarity of any solution. Okay? So molarity, which is this C, is given as the mole of the solute divided by what? The volume of the what? Solvent. So we can also say that C is equal to what? N over V. This is the short form of this formula, where C represents the concentration. Okay, let's explain the value. C represents concentration in mole per dm cube, or you can say that C represents what? The molarity of the solution, where N is equal to what? Number of what? Moles, which is already stated, and V is volume of the solution in what? In dm cube. So this is the first formula you have to know for molarity. The first formula you have to know for molarity is that molarity is what? The moles of the solute over what? The solution. Remember that you have, for you to form a solution, you need what? A solvent and what? And a solute. So the mole of the solute required to dissolve in 1 dm cube of any solvent to form the solution is the what? Molarity of that solution. Also, this molarity we are talking about can also be calculated from knowing the mass concentration of any solution and the molar mass of the compound involved. So mathematically, molarity is given as mass concentration, the concentration in terms of the mass, which is usually in gram per dm cube, divided by the molar mass, which is in what? Gram per mole. Okay? So when you work it out, you see that the unit you get is the unit for molarity. How do you work it out? Remember that G over dm cube times mole over what? G. So G cancels G. You have mole per dm cube. Right? So this is still the unit of what? Molarity, which is this what we have here. So with this formula, we can actually calculate the mass concentration if we know the molarity of the solution and the molar mass. Okay? So we can simply say that the mass concentration is equal to molarity times molar mass. So with this, we can actually relate the molarity and the mass concentration using this equation. Okay? So from here, we can evaluate this. If you know this, you can get this. If you know this, you can also get this. Molar mass. you should be able to know how to find molar mass. Molar mass is simply the sum total of the what? Atomic mass multiplied by the number of atoms it appeared, right? For example, you know how to do it. If I have something like, let's say, I have sodium triazocarbonate 3, and I say find the molar mass, you know what to do. Sodium is 23, carbon is 12, oxygen is what? 16. So how do you do it? It's equal to 23 times 2, you close the bracket, plus carbon is 12 plus 16 times 3. So when you add, multiply and add, whatever you get becomes the molar mass, which is the value you put either here or here, depending on the problem you are solving. Now, let's look at another aspect of this molarity or concentration in mole per dm cube. Now, most of us have heard about the reaction called acid-base reaction, otherwise known as neutralization reaction. A reaction between an acid and what? And an alkali in equal proportion to produce salt and water, which is the product of the reaction. Now, for such reactions, you are reacting the acid with a given concentration, a given volume, and also the alkali with a given concentration, a given volume. Okay? So there is a relationship between these two reactions. There's an equation we can generate that can help us attempt some questions that involves acid-base reaction. Okay? So that equation is called, we can call it the titration formula or the titration equation. So how do we get that equation? Let's assume that we have A reacting with B to produce C, and these are salt and our water, right? Just an assumption, okay? And let's assume that after balancing the equation, we have small letter A and small letter B to balance the equation. Remember that from your knowledge of molarity or concentration in mole per dm cube, we told you that C is equal to N over V, right? What you are seeing here, this expression is the same thing as CV is equal to what? N, right? So it means that for the acid, if we are referring to the acid, we have CaVa or CaVa is equal to what? Number of mole of the acid, which is small letter A. Take note, the Ca means the concentration of the acid, because C stands for concentration of the acid, V stands for volume of the what? Acid that is needed for the what? Reaction to proceed. So CaVa represents this for this. Na represents the number of mole of the acid that reacted with the what? Base. If you carry out for the same thing for the base, we have CbVb is equal to what? Nb. Okay? So combining these two equations, we came about with the equation responsible for solving problems that has to do with reaction between acid and base. So without proving further, we have this expression: Ca over Cb divided by Vb is equal to Na over what? Nb. So we only use this equation whenever we are looking for one of the parameters. Okay? Everything must be given to you, or you must know how to get everything before you can be able to apply this formula. You can't be looking for two things at the same time, and this equation works. Okay? This equation works when all the parameters are known except one parameter. Remember that these two are gotten from the balanced equation. So the moment you balance an acid-base reaction, look out for the number you see here. If it is 1, you put 1 here. If it is 2, you put 2 here. So the moment you have all the parameters in check, you can now go ahead and make what we are looking for here subject of formula. Remember that the Ca represents the concentration of the acid. The Va represents the volume of the acid. If it's a practical aspect of this course, the Va is talking about the end point. The end point. At that point where there is a color change, the net average value of those endpoints will give you the Va. Okay? The Cb represents the concentration of the base or the alkali needed for this what? Titration or for this reaction. Okay? The Vb is always the volume of the pipette. If it's a practical question, that pipette, either 20 or 25 cm cube that you use for this experiment, titration, is normally the volume of the base. Okay? You pipette it and then add your indicator, and then carry out the experiment and run it over through the acid, run the acid over it, and then when there's a color change, that is your endpoint. So it means that the acid has been able to react with the base to produce the salt and the water. So the Na and the Nb are usually gotten from a balanced chemical equation involving the acid and the water and the base. So this equation works when all the parameters are known except one parameter. You can make anyone subject of formula. I hope you know how to make something subject of formula. If you don't know how to make it, if you don't know how to do that, let me assist you. Let's try to make Ca subject of formula here. If I do that, Ca becomes Cb Vb Na all over Va and B. Do you understand how this happened? I'm looking for Ca. So I will do this times this divided by these two. When you cross, the one you cross first, you multiply. Then the other one that is close to the one you are trying to make subject of formula, you now divide it with that. Let's do for Cb. If I'm looking for Cb, for example, let's say I'm looking for Cb. I'm looking for Cb. How do I do that? I'm looking for this. You cross again. These two, this one will multiply. Then these two that are close to this one will divide. So what do you have? You have Ca, Va, Nb all over Vb and Vb and A. Does that make sense? Yes. So from the expression, you could see that I have successfully made this subject. So we can use this to solve for Ca. You can also use this to solve for what? For Cb. So you can also make any one, whether the volume of the acid or the base, depending on what you are looking for. You can also make this out of the formula and get whatever you are looking for. So this is what we call the equation that relates the acid and base in terms of what? Neutralization what? Reaction.